All right, so let's take a look at this one. This is again a classic algebra 2 problem that we're just going to start out by kind of proving. The rate of change of n is proportional to n. When t is 0, n is 250, and when t is 1, n is 400. What is the value of n when t is 4? So I plotted the points. I plotted a curve, okay, that I think follows the points. Now remember, do I have enough info using this? I know k is a constant that we don't know, but you should get the idea that if n is 0, it's all flat. If n is 1, the slope would be like a slope of k, and then it gets steeper and steeper, and that's the slope field, and that blue is the separate and integrate part that shows me the route through that slope field. If n is negative, I have negative people. I don't know if that's like Walking Dead or something like that. Then you are going to lose people. And that path would look something like that. Doesn't look really lined up with my tick marks, but you get the idea. That black should flow through the tick marks a lot better. I apologize for that. Okay. All right, so we solve. Okay. So as a reminder to solve, you'd have dn over n equals k dt. Separate ln of n equals kt plus c. E it, n equals c e to the kt. Now, two things that you should be getting good at. You don't really fully know why, but when you do e to the ln, I told you, you can just remove the absolute value. You'll understand that a lot clearer today in the notes. And then remember, e to the kt plus c is c e to the kt. Now from that, you can plug in points. The first one I'm going to use is the 0, 250. You get 250 equals c e to the k times 0. You like it when I give you initial one, because then that makes c be 250. So now I have n is 250 e to the kt. Now I get to plug in some other point, which was 1, 400. So 400 equals 250 e to the k1. So 400 over 250 equals e to the k. 40 over 25. Let's see, that is 8 over 5 equals e to the k. So then that means k equals ln of 8/5. So I can now write n equals 250 e to the ln of 8/5 times t. We worked on this before, that you can now say n equals 250 8/5 to the t, and now you can go solve some more things. Is this the exact same problem as what we started with today? I hope not. Let me go check real quick. It's the exact same problem, and I apologize. I did not think through that. Oh well. Anyways, moving on. So here's one, Newton's law of cooling. Okay, so it has lots of wording here. Reminder, this is what we ended with yesterday. The rate of change in the temperature of an object is proportional to the difference between the observer's temp and the temp of the surrounding median. Let y represent the temperature in Fahrenheit of an object in a room whose temperature is a constant 60. If the object cools from 100 to 90, 10 minutes, how much longer will it take for the temp to decrease to 80? I color coordinated all of the wording of Newton's law of cooling to make sure you're comfortable with dy over dt equals k. That's all the proportional part. And then the green is the difference between your temperature and the surrounding median. Yesterday in the notes, I think I used big T instead of Y, but you can use Y if you want. Okay, I'm going to separate. Notice I bring that whole Y minus YM all over. Get to here. I'm going to E both sides to there. The absolute value goes away. You don't need it because I have the fuzzy math going on. And I get to this. Okay. Now, okay, so you can plug in points. Let's see. I started at a constant of 60, and I started at 100 degrees. So the YM is 60. Now, it's funny. You guys know you start at 0, 100, and so many times last year when I graded this test, the Newton's Law of Cooling question, for C, they put in 100 because they keep thinking C is your initial condition. It's not, though, because look what happens when I plug in 100 and I plug in 0 for the T. C does not become 100. It does if you don't have that plus 60 part to it, but you do have the plus 60 part to it. So C becomes 40. So I have it this way. Realize that the 100, if you're going, wait, where'd the 100 go? Well, the 100 is basically 40 plus 60. Okay, if you put in 100 for that C, you would be saying your initial temperature is 160, which it's not. So I have this, and plug in 10, 90, you'll get the K. And then you can plug in the next point to go figure out when it will cool to 80. All right, now we're going to dive into some of the problems with pluses and minuses. I kind of mentioned that earlier today. So let's take a look at this one. dy over dx equals negative x over y. I quickly drew the slope field for you, and we've done this one before. You get circles out of this. Okay. Now, I'm going to give an initial condition of either 3, 4 or 3, negative 4. And we're going to try and figure out what part of the circle you should get. Okay. Some of you might go, wait a second. Yesterday when we did do this, we didn't get a top half or bottom half. We got the whole thing. I need to clarify that today. If you are a ball and you get placed at 3, 4, you are only allowed to follow the train track that is a function, which means you're only allowed to stay on the blue. If you started down below, you would only be able to stay on the green. Yes, the green and the blue make the complete path of that black circle, but here's the issue. If you're a little particle, let's say you're a little smiley face here, and you're starting to go on this train track. Oops, lots of smiley faces apparently. Here we go. Right there, 3, 4. Can you tell me the slope? You should be able to tell me the slope right there. The slope right there at 3, 4. You could find it from the slope field. You could plug into the slope field here, and you would get negative 3 over 4 is your slope. Okay, so you know how you're driving your train on the train tracks. Over here you could get it, but right here, right there, and you're trying to drive the train there, all of a sudden you would be getting that point. I know for sure that point is 5, 0. Then that slope would be negative 5 over 0, which you and I are starting to agree is kind of a vertical slope, but that's an undefined slope in the world of the train, meaning, I don't know what to do. I don't know what to do. So he can stay on the blue. He could stay on the green if he started on the green, but right there where the blue and the green connect, the slope is vertical or it's undefined, and that overwhelms the train. And so it can't pass through the blue and connect to the green. So my goal every time I separate and integrate is when you solve for a y equals, you're trying to find a function. And in that function, it might be the plus version of that function, or it might be the minus version of that function. That's what we're going to work on today. So if I say 3, plus 4, you're trying to find the the blue route. If I say 3, negative 4, you're trying to find the green route. And the only difference between those two routes is the plus or the minus. So let's see this. If I'm actually going to solve it, I'm going to have to separate, and I'm going to integrate. So I get y dy equals negative x dx. Integrate. 1/2 y squared equals negative 1/2 x squared plus c. Here comes my fuzzy math. Multiply by 2. Y squared equals negative x squared plus c. It should be plus c. You could say plus 2c if you want, but my fuzzy math tells me 2 times c is the same as c because it's just a number. Okay. Now, if you wanted to show the generic overall path, you could add over the x squared, and you have the generic path. That is showing a circle with radius square root of c. If you wanted to take the square root, you could say y equals the square root. If I do the positive version, I got negative x squared plus c. Or you could say it's the negative version of the square root, negative x squared plus c. So all three ways are technically correct on basically what are you trying to tell me. I can say the overall path is black. I can say the top half is blue, or the bottom half is green. Okay? And in general, if I don't give you an initial condition, any one of those is fine. Okay? I would probably do the black if I do not give you a general starting point. But if I do give you a starting point, you need to make sure you know it's either the blue or the green. Okay? So the initial condition here, if it was 3, 4, would belong to blue. If it was 3, negative 4, it would belong to green. Okay? So, and if you had either one of those over here, you will still get the same C value. And all of these, when you solve for C, C becomes 5. No, 25. Sorry about that. 3 squared plus 4 squared. Yep, 25. And all of them you get 25, but if you wanted a specific one like the 3, 4, you'd say positive x squared plus 25. Okay? If you're doing the green one, you would have to say specifically negative x squared plus 25. The black one doesn't have a plus or minus in it because you never took the square root. So the black one, you would just be saying x squared plus y squared equals 25. But then when you tell me it is going through the town at 3, 4, you need to realize that's only the blue guy. Okay? Let's take a look at another one. Okay? We've talked about this one many times. dy dt equals kt. And when you graph this guy, it looks like flat, 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 flat. Up, 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 up. Steeper. Steepest. Negative. Negativer, if that's a word. More negativist. And we've drawn this one many times, and I've called this the train depot. And if you do not, if you have an initial condition of, let's say, -5, 0, you are going to stay flatlined, and you will never get off that. If I give you a point up here, and let's say it is 2, 3, then it's going to peel above the ground, and you're going to get a positive version. And if I start here and I peel down, let's say through the point 2, -3, you're going to get a negative version. And I want you to see all of that through the pluses and minuses. Okay, give me 1 second. Okay, so when you separate dy over nothing equals k dt, y equals k, oh, sorry, this should be ky here. I apologize for that. Let me start this all over. I knew it felt fishy. So this would be dy over y equals k dt. Integrate ln of absolute value y equals kt plus c. we E it, we E it, we get y equals CE to the KT. Okay, watch what happens if I decide to plug in -5, 0. I get 0 equals CE to the K times -5. I get 0 equals CE to the -5K. When you solve that, e to the -5k is never 0. So the only thing that can make it 0 is if c is 0, which makes your path 0. Okay? If I decided to do 2, 3, I would get here 3 equals CE to the K2. 3 equals CE to the 2K. Now, I know I need another point when I do growth and decay problems. Normally that point is your initial value. But let me just ask you this. E to the 2K. What is E to the 2K always? Positive. And if I have 3, which is positive, what does C have to be? A positive. So I know I haven't solved it all the way, but I know it's going to be a positive CE to the 2K. And likewise, if you have the purple, the only way you could have the purple would be y equals -CE to the 2K when you're when you're solving for the 3. You would have that there. And here you would have the 3 there, but you know it has to be negative because this is a -3. And if this piece is always positive, then this piece has to be negative to force the negative fit. Okay? Now, let's talk about why the absolute value can go away. I want to take this piece of it, and I want to say I leave that as ln of y equals kt plus c. If you plug in 2, 3, or 2, -3. So if I plug in 2, 3, or if I plug in 2, -3, I want to show you what happens, and we'll see if there's a debate or not. Either way, I'm going to get ln of plus or minus 3 equals 2k plus c. Since it's absolute value, I'm getting ln of 3 equals 2k plus c. From there, when you look at it, c is going to be the ln of 3 minus 2k. Now here's the thing. The red route, I knew it was a positive c. The purple route, I knew it was a negative c. And currently here, I'm just getting a c. Now here's the thing. I don't know who k is yet. Do you guys agree with that? So since I don't know who k is yet, I can't tell you if c is positive or negative. But let's just say c becomes a positive. Okay, again, I'm sorry, you don't know who k is. If c is a positive here, when you write it, you're going to have ln of y equals c, no, sorry, ln of y is kt plus c. And when you e it, when you e this thing, you're going to get y equals CE to the KT. And if I already told you it's positive, you might be going, does that mean it's positive? No. You need to have in your moment here, just like when you square root, you have to say plus or minus. When you e, you are technically supposed to say it's a plus or minus version. That's the real reason, because really, instead of a plus or minus, I really should say absolute value of y is CE to the KT, which means it's either going to be y equals CE to the KT, or it's going to be y equals negative CE to the KT. You don't know which version it is until you know which way you start. So there is that plus or minus part in that section as well, but you can avoid saying plus or minus by just plugging in the points later. Okay, I think I confused some of you guys, so luckily I have another couple practice problems on the next video.